I am going to go ahead and give the notes and do some examples from the last topic in lesson 15, problem solving with systems of equations. Okay, the first step, if you're going to solve a story problem that involves a system of equations, you'll be looking for two unknown values. At the end of the story, probably the last sentence will have asked for two particular values. And what you need to do is assign a variable to represent each of those unknown values. Next, you'll reread the story and use the information that's given to write two equations that each have the two unknown variables, or the two variables from step one. A lot of times, each sentence will turn or translate into its own equation. Sometimes one sentence will have two equations in it. It just depends. And then last, of course, we need to then solve the system of equations that you wrote. So either use substitution or elimination. And then after you've solved, check to make sure the answers you got are reasonable and answer the question. So with this first equation, or the first story problem here, it says the sum of two numbers is 40. Remember, the word sum means addition. And their difference, that's subtraction, is 84. What are the numbers? Okay, what are the numbers? The two unknown things in this case are two numbers. So I'm going to just say x is one number and y is another number. Or I'll just say other number. That works better. Some of the stories will talk about a larger number and a smaller number. And so you'll use that to be a little more descriptive, but in this case, one number, other number. I will require you to do this on your quiz and test over this material, so I'm going to box it. It's critical. It'll lose some credit if you don't do this. Okay, then we need to write the equations using x and y in both equations. Well, the first part of the sentence says that the sum of two numbers is 40. So I'm going to take that right there and go ahead and write the equation x plus y equals 40. The other half of the sentence says that their difference is 84. In other words, if I subtract x minus y, it will equal 84. So those are my two equations. And now I need to solve this system. I need to be able to see your equations. So this setup is perfect for using the elimination methods. That's what I'm going to do. Let me just ask you to try not to cross out your original equations or to X things out so that I can't see your equations anymore. Okay, in this case, the x plus x, 1x plus 1x is 2x. The plus y and minus y cancel out. And 40 plus 84 is 124. And if you divide by 2 on both sides, we get x is equal to 62. I can then take that answer and plug it into one of my original equations. So x plus y equals 40 becomes 62 plus y equals 40. If I subtract 62 on both sides, y is equal to negative 22. So that's my solution. And because it's a story problem, you need to briefly answer the question. The answer to this question would be the numbers are 62 and negative 22. And you can check that If you add those two numbers, the sum is 40. And if you subtract 62 minus negative 22, they add up to 84. Okay, the second question on the worksheet says there are 812 students in a school. The number of girls is 36 more than the number of boys. How many boys attend? How many girls attend? So the unknowns are how many boys, how many girls. We could use X and Y, but I think B and G make more sense. Okay, if those are the two variables, then we need to now use them to write our equations. Well, the first sentence says there are 812 students in a school. If there are 812 students in the school, that's a total. And so I can say that B plus G must add up to a total of 812. So that first sentence I've translated into the equation B plus G equals 812. The second sentence says the number of girls is 36 more than the number of boys. There are a lot of different ways that you could interpret that sentence to make an equation, but the most literal interpretation would be this: the number of girls is or equals 36 more than the number of boys. So I'm going to say this: G, number of girls, is or equals 36 more than the number of boys. If I want 36 more than the number of boys, I'm going to take B and add 36. Okay, sometimes the student might want to write the equation G minus B equals 36. That's fine. That's just a different form of this same equation. So these are my two equations. Okay, in this case, they're not, at this point, it's not set up for elimination. It's set up for substitution. So let's just review how to use substitution to solve this system. If G is equal to B plus 36, then I can take B plus 36 and replace G in the first equation with B plus 36. So it will look like this: B plus 36 equals 812. Which means I have 2B plus 36 equals 812. If I subtract 36 on both sides, oh boy, it's early in the morning. 776 hopefully. And then I have to divide by 2 on both sides. Need a calculator. 350, 38, 388, 388 boys, which means take 388 and add 36. I can't do it. I cannot do it. I gotta write it on the page. Okay. G equals 424. Okay, answer. There are 388 boys, 424 girls. And then you should check that with a calculator. Does that add up to 812? And is the difference, are there 36 more boys? Wait, is the number of girls 36 more than the number of boys? So you can check it out, make sure that it adds up.